Okay, so we will see the some of the classical crypto system, which are typically old crypto system or which are conventional crypto system. So, we start with a so we know the crypto system is a 5 tuple P, C, plain text space, ciphertext space, key space, and set of encryption algorithm, set of decryption algorithm. Okay, so we will start with the cipher, which is a classical crypto system, which is very old crypto system. So, these are all symmetric key crypto system, conventional cryptography. Okay. So, in here plain text space is Z26, which is basically 0 to 25. So, that means if you take any integer and if we divide that integer by 26, then it will give us the remainder from 0 to 26. Say for example, if we have 28. Now, if we divide this by 26, that means 28 mod 26 is basically 2. So, this is basically if we divide any integer by 26, you will get this remainder 0 to 25. So, this is typically called Z26 set. Okay. So, this is our plain text space, and this is also our ciphertext space. So, ciphertext space is also Z26, and the key space is also Z26. Okay. So, we define the plain text space, ciphertext space, key space, and now we need to choose an encryption algorithm for this cipher. So, in cipher encryption algorithm is like this. The message is so EK. So, this is the encryption function. So, this is cipher encryption function. So, EK of M is the message, which is basically, or M or K we can take as the plain text. So, it is basically x plus k. So, x plus k, x is 26, Z26, k is Z26, but x plus k could be more than 26, because if it is 20, then it is 40, just addition, real number addition. So, 40, but 40 is not belongs to G, because our ciphertext space is Z26. So, to make it Z26, what we need to do? We need to take the mod. So, mod 26. So, this is the encryption function. So, if you take the mod 26, then this is our y, and y very much belongs to Z26. This is the ciphertext. So, this is the plain text x, and this is the y is the ciphertext. So, this is the encryption, this is the cipher encryption. And what about decryption? So, decryption is basically dk of, so for decryption input is y is the ciphertext with the same key, this key should be same, it is basically y minus k, again we have to take the mod 26. So, this is the decryption function of cipher. Now, for k is equal to 3, this is called scissor cipher. Okay. So, let us take so this is the cipher. So, we are taking Z26, which is basically this set, and these are our all plain text, ciphertext, key space, and if we choose a key from this Z26, and this is the encryption, we just add this key with the number and we take mod 26. Why this 26? Because we will be seeing that we will be encrypting the our plain text as the English alphabet, English text. So, if you take the English alphabet, it is starting from A to Z. So, A to Z means it is basically how many 26 elements are there. So, 26 letters are there, A, B, C, D up to Z. So, 26 letter we can have a 1 to 1. So, this is typically A, this is B, this is C, and this is Z. So, this is we can have a one-to-one correspondence. So, we can have a one-to-one correspondence between between this English letter to A, B. This is the English alphabet set Z26 by this correspondence. So, 0 means A, 1 means B. So, we want to encrypt English letter. So, that is why we want to take Z26, because our English alphabet is are basically 26 letters are there. So, 26 letter means we can just typically assign 0 to 25. So, 26 letter. So, this is the SIP cipher. So, we just take the 26 and we add in mod 26, and Caesar cipher is the particular case of SIP cipher where k is 3. Okay, so, this is the example. Suppose our plain text is the English text, we want to use the English text as our plain text, and now we have this correspondence between alphabet character, between the set of all alphabet A to Z and Z26. So, A means 0, B means 1, C means 2, D means 3, E means 4, like this. So, this way we continue. This is the one-to-one correspondence. So, 23 means X, W means 22. So, this is the one-to-one correspondence we are going to use for our encryption and decryption process. So, that is why we take the Z26 mod 26, that is the reason we have to take mod 26. Okay. So, now let us take an example of encryption. Suppose we choose Alice and Bob, they choose the key. So, key has to coming from the Z26. Key has to come from Z26. So, this is the two party Alice and Bob, and they are using the SIP cipher for their encryption purpose. So, now suppose they agree with a common key k is equal to 11. So, they somehow decide that they are going to use k is equal to 11. Now, suppose they want to, so Alice want to send a message, this plain text, that we will meet at midnight. Suppose this is the message Alice want to send to Bob. So, this is our plain text, we will meet at midnight. So, this is the plain text Alice wants to send to Bob. So, what Alice will do? Alice will so Alice will just convert it into the corresponding letters, I mean from Z26, because for encryption we need to do the addition. So, we cannot do the addition in the alphabet, shifting we can do. So, this is basically letter shifting. If we add 3, that means A is going to D. So, this way Caesar cipher is 3 shifting. So, that means A is going to B, C, D. So, this way. So, Caesar cipher was invented before the SIP cipher, but it was not coming from the Z26 sense, it was just coming from the shifting the alphabet. Okay. So, basically we convert this so we will meet at midnight. So, we convert this to corresponding the sequence of integers. So, W means 24. So, if you just remember this correspondence, so W means 22. So, this is 22, and E means what? E means 4. So, this is the 4, again W 22, I is what? I is basically 8. So, I is 8. So, L if we see this correspondence, L is 11. So, we have 2 L's, 11, 11. So, we convert everything into the integer. So, that by that correspondence between set of alphabet to Z26, and then we have chosen a key k. So, that is our secret key. So, we just add this key with this. So, basically we will be getting this. So, if we add 11 with 22, so it is basically coming out to be 33, but 33 is what? So, basically we are having, so let us just do it. What is the plain text? Plain text is we will meet at will meet at midnight. So, this is the plain text. So, just if we follow the one-to-one correspondence between these and alphabets, these alphabets and the Z26, we have 24, 4, 24, then 8, 11, 11, then 12, 4, 4, 19, 0 like this. Okay. So, now key is 11. So, we will just add 11 with all of this. So, our encryption algorithm is basically x plus k mod 26. Okay. So, after this addition we have to take the mod 26. So, this is 33. So, 33 mod 26. So, this will give us basically 7. So, this has no problem, this is 15. So, this is again 33 mod 7. So, this is 19 plus 11 like this, 22 like this. So, this is the way we just get the ciphertext stream. I mean, this is the ciphertext stream in integer form 7, 15, 7, 15, 7, 19, 22, 22 like this. So, this is coming out from this plain text by adding 11 with the 11 is the key. By adding 11 and mod 26 we get this ciphertext integer, and now we convert this into the alphabet again. So, 7 means basically, let us come back to the one-to-one correspondence. 7 means basically H. So, H, and again 15 means let us come back, 15 means P. Okay. So, this is P, again 7 means H like this. So, this is the ciphertext. So, this is the ciphertext corresponding to this plain text, we will meet at midnight. So, this ciphertext is sent to Alice over this public channel, to Bob by the Alice over this public channel. This is H, P, H, T, W, W, X, P, P like this. Okay. So, this is, I mean, from by, so Oscar is having access to this. So, Oscar is seeing this ciphertext. So, this is the ciphertext and this is the plain text. This is the plain text or the message, and this is the ciphertext. So, it is very difficult to guess from here what was the plain text. Okay. So, this is the SIP cipher. Now, how Oscar, but Bob has to get back the message. So, what Bob will do, after receiving this ciphertext, Bob will just convert it into the integer again. So, H means 7, P means 15, again H means 7, 19 like this. So, Bob will get the integer again, the sequence of integer, and now Bob has to apply the decryption algorithm. So, decryption was like this, dk of, so Bob has to use the same key dk of y minus k mod 26. So, Bob will just convert this H to, so H is 7, then P is basically 15, 7 and then 19 like this. So, what Bob will do? Bob will decrypt minus 11, minus 11, minus 11, minus 11. So, every time it has to be mod 26. So, if you do this, this will give us 22, this will give us 4, this will give us 22 again, this will give us 8 dot 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 like this. So, just if we convert this integer into the alphabet again. So, 22 means W. So, this will give us, we will meet at midnight. So, this will give us the original plain text back. Okay. So, this is the decryption process. So, this is typically done by the Alice. So, Alice is just subtracting 11, the key the secret key shared between Alice and Bob, and get back the corresponding plain text, and then Alice convert this integer to the alphabet and get back the message sent by the Alice. So, this is done by the Bob, this decryption. So, Bob will get back the message. Okay. So, as we know, Caesar cipher is a particular case of this SIP cipher, where we choose k is equal to 3. So, just basically we are shifting all the alphabet are shifting 3 positions. So, if we have a plain text like A, so A will shift to 3 positions. So, A is 0. So, 0 plus 3, it is basically 3. So, 3 is basically D. So, A, B, C, D. So, A is coming, if the plain text is A, then the ciphertext is D. So, we are basically shifting the alphabet position 3 times. So, this is the Caesar cipher, which is a particular case of SIP cipher by choosing k is equal to 3. So, if this is our plain text, then the ciphertext will be the same, this thing, the ciphertext, and then for decryption again we have to come back. So, this is the circular shift. So, if we have Z, so Z means A, B, C. So, Z is the last one. So, Z will shift to 3 bit next. So, this is the circular way shifting. Okay. So, now come back to the security issue of this SIP cipher, whether SIP cipher is secure or not. So, we want to talk about cryptanalysis of SIP cipher that Oscar will be doing. Okay. So, cryptanalysis of SIP cipher, whether SIP cipher is secure or not. So, what Oscar is getting? Oscar is getting a basically ciphertext, but this ciphertext is basically coming from the plain text, which is a typically English text, we know for this case. Now, what is the key space? So, Oscar knows the key space is basically Z26. So, key is basically from 0 to 25. So, Oscar knows the key is coming from 0 to 25. Oscar does not know which one they have used as a key. So, Alice and Bob, they are communicating, they have chosen a key which is from Z26 and this is secret, Bob is not knowing. So, they are communicating. So, now this channel is typically captured by the Oscar. This is a public channel, nothing to capture. I mean, this is everything is public in this channel. So, this is the now Oscar knows. So, they are using the SIP cipher. Oscar knows that they are using SIP cipher. So, Oscar knows that this plain text was encrypted by this way mod 26 and this is the y. So, Oscar is getting y. So, only thing what Oscar is not knowing is the secret key. Oscar does not know what is the value of k, but Oscar knows that they have used SIP cipher. This encryption algorithm must be public. So, we cannot hide that what algorithm we have used, whether we have multiplied, whether we have added, whether we have subtracted, that you cannot hide, that should be public. This is the model, this is the model we use, this is the Kirchhoff's model. So, we cannot say that okay, I will not reveal whether I have used addition or I have used multiplication or I reverse the bits. So, that you cannot say. So, that algorithm must be public. So, whatever we have used for the encryption, that algorithm is public, only secret is the k, this is the secret. So, this k is the typical secret. So, now well Oscar is getting this y, which is the ciphertext, and Oscar knows it is coming by adding with the plain text, but Oscar does not know how much it has added. That means, Oscar does not know what is the value of key, but Oscar knows the key is coming from this set 0 to 25. So, Oscar can try for all possible case. So, this is the brute force way or exhaustive search. So, Oscar can try for k is equal to 0 and Oscar will check y minus k and m whether any meaningful things is coming out to be this like this. So, Oscar will try for all possible case k, but here key space is very small, it is just 26. So, just 26 attempt Oscar can guess or Oscar can reveal the plain text. So, this is the brute force method. So, just we have to perform the 26 Oscar need to perform the 26 possibilities of the key. So, given a ciphertext string Oscar successfully try the decryption process with k is equal to 0, 1, 2 like this until get the meaningful text, because we know that our encryption is English text. So, once Oscar get a meaningful text Oscar will stop. So, let us take an example. So, here is an example. Suppose Oscar is Alice and Bob, they are communicating with each other and this is the ciphertext Alice sent to Bob and they have using the SIP cipher. This is public. They are using SIP cipher. Oscar knows that they have used SIP cipher. Only Oscar does not know is the key, how much they have added, the value of k. So, what Oscar will do? This is the brute force way or exhaustive search way. So, Oscar will try for k is equal to 0. Oscar will, this is no change because this is the same. This is the decryption Oscar is doing. K is equal to 1. So, Oscar will convert this into the digit and Oscar will subtract 1 mod 26. Oscar gets something. This is also nothing too much interesting. K is equal to 2. Oscar will choose. This is also now not much interesting. Then k is equal to 3, also no meaningful text is getting. K is equal to 4, something no meaningful text. K is equal to 5, no meaningful text. K is equal to 6, no. Then this way Oscar will continue and suddenly at k is equal to 9 Oscar will realize, yes, we got a meaningful text. So, this is the plain text. So, and Oscar is getting the key. So, Oscar is now got the key. So, Oscar now have the key which is shared between Alice and Bob secretly. So, that key is 9 here. So, now Oscar will come to know everything about what they are communicating. So, this message is already revealed. So, Oscar got this message, this is a meaningful message. So, Oscar is ensured that the key is 9. So, now for the further communication also Oscar will just use the decryption algorithm of the SIP cipher and Oscar will get back the message. So, this is the cryptanalysis on SIP cipher and that is why SIP cipher is not secure. So, SIP cipher is not secure because the problem is with the key size is very small. So, now what to do? So, SIP cipher is not secure. So, just by 24 attempt 26 attempt Oscar can get the key. So, now we will talk about something more key space. So, this is also a classical crypto system which is called substitution cipher. Substitution cipher. Okay, so here key space and ciphertext space is set of all alphabets, set of English alphabet. So, that means it is basically this set A, B, C, D like this up to Z. So, for P we use the small letter just for show the difference between the plain text and this is the plain text. We use typically small letter for P and for C we use the capital letter. Okay. Now, this is the plain text space, this is the ciphertext space. So, these are all English alphabet. Now, our key space is basically a key is typically a permutation on this alphabets. So, permutation is basically a bijective mapping. So, it is a permutation phi from this set to itself. So, this is the set of alphabets, we denote this set by say A is the set of alphabet. So, it is a bijective mapping from A to A. So, this is a permutation. So, that means, if we have A, B, C, D like up to Z. So, A can go to C, B can go to D, the C can go to P like this. So, this is a permutation. So, just a suppling. So, linear permutation. So, how many such permutation are there? So, there are 26 symbols. So, 26 factorial. So, this is the key space. So, set of all permutation from this set to this same set, this is a bijective mapping, bijective function. So, this is the key space, this collection of all permutation. This is basically a permutation from permutation on A. So, this is our key space. So, our key is basically a permutation, you have to take a permutation as a key. Okay. So, then how we will apply? So, this is our plain text space, this is our cipher text space, this is the key space, set of all possible permutation on 26 alphabets. So, there are 26 factorial permutation are possible. So, now encryption is basically we take a permutation and we take a symbol, and this E of phi is basically the permutation of this phi of x. So, we will come to an example, and D of phi is basically the inverse permutation on this. So, inverse permutation if we apply, we will get back the message. Okay. So, this is the typical substitution cipher encryption and decryption. Let us take an example. Suppose this is the permutation we are using. So, this is one permutation, there are 26 factorial such permutations are there. Okay. So, this is a permutation say phi. So, A is going to x, B is going to n, C is going to y like this, P is going to L, Q is going to R, R is going to C, S is going to V like this. So, this is one permutation phi, we denote this by phi, and this is the corresponding inverse permutation. That means, A is going to D, where is D? So, D was going to A. So, if we take the inverse permutation, that means, A is going to D by the inverse, this is the phi inverse. Okay. So, this is the permutation. Now, under this permutation how we can encrypt? So, encryption is basically, suppose we have the plain text like this. Yeah, suppose we have the plain text like this, meet me, sorry, meet me. Okay. So, this is the plain text. So, what we do? So, now m, so we have to apply. So, m will be converted into phi of m, and E will be going to phi of E, phi of E, phi of T, again phi of m and phi of E. So, if we use this phi, so phi of m is basically m is going to, here if you observe m is going to T. So, this is basically T, and phi of E. So, E is going to, if you just look at this phi, E is going to H. So, this is H, this is H, again T. So, T is going to where? Under this permutation, T is going to M, and again M is going to T, and E is going to H. So, this is the cipher text. So, this is the plain text, and this is the cipher text. So, this Alice sent to Bob over this public channel, and so this is Alice, this is Bob. So, Alice sent this T H H M P H to Bob. So, what Bob will do? Bob has to, so this is the ciphertext Alice sent to Bob. So, Bob has to get back the message. So, what Bob will do? After receiving this, Bob will apply the decryption algorithm. So, decryption algorithm for substitution cipher is just the, we need to apply the inverse permutation on it. So, phi inverse of t, phi inverse of h, phi inverse of h, like this. So, phi inverse of t, if you take the inverse permutation, phi inverse of t. So, let us come back t, phi inverse of t is m. So, this is basically m, and phi inverse of h, phi inverse of h is e. So, e, then this way. So, we will get back meet me. So, this plain text. So, this is the plain text we are getting back by this applying the this decryption algorithm, which is the inverse permutation. Okay, so, now next we will see whether this is a secure or not in the next class. Thank you.